Hello. Today we're going to be looking at right triangles, and we're going to be trying to solve for sides of right triangles. Before we do that, we should learn some definitions. The hypotenuse is a side that's always opposite the right angle in a right triangle. So in this triangle, our right angle is here, so opposite of that will be this side. That's the hypotenuse. While this one on the right-hand side has a right angle in the lower right-hand corner, so we go opposite of that, and this is our hypotenuse. Now, as I'm struggling spelling hypotenuse when it's on the paper, now we can move on to legs. Legs, the sides that are not the hypotenuse. So that's a leg, and that's a leg. So legs are just the two other sides. Now, one other thing that we should know about the hypotenuse is the hypotenuse is always the largest side in a right triangle. It's always the largest side of the right triangle. Now, if we take a right triangle, and it looks like this distance is 1, 2, 3 units. This distance is 1, 2, 3, 4 units. And this distance is 1, 2, 3, 4, 5 units. So automatically we know 5 is our hypotenuse if this is a right triangle, and the angle opposite to that would be 90 degrees. Now there's a property with right triangles where if I take this side and make a square out of it, which is 3 by 3, that would make 9 boxes. If I take a square out of this side, that would be 4 by 4, which would make 16 boxes here. Now I would have a 5 by 5 box, which is 25. Now you have to think about these numbers. What connection do we have between these numbers? Hopefully you're saying 9 plus 16 is equal to 25. And we get 9 because it's 3 squared, 16 is 4 squared, and 25 is 5 squared. And this goes back to a squared plus b squared equals c squared, which I hope you guys have seen before. That is what we call Pythagorean's theorem. In a right triangle, if a and b are the lengths of the legs and c is the hypotenuse, then we know a squared plus b squared is equal to c squared. Now find the third side in this right triangle. Well, this is our right angle, so 13 would be our c value. So if this is a, this would be b, so we'd have 5 squared plus b squared is equal to 13 squared. Or 25 plus b squared is equal to 169. If you subtract 25 from both sides, you get 144. The square root of 144 is 12. So b equals 12 centimeters. Wonderful. Now, the third side in this triangle, I know my right angle is down here. If I go opposite, that's my c. So the c in this case I don't know. So I'll do 8 squared plus 15 squared is equal to c squared. 8 squared is 64. 15 squared is 225. If I add those together, I get 289 is equal to c squared. And now I square root both sides, and I have the square root of 289 is equal to c. Now if we take the square root of 289, we would get 17. So that is our value for c. Now this gets a little trickier. If this side is x, and these two sides are the same, and that's a right angle, this side would also have to be x. So let's find an equation for our hypotenuse. Well, we take x squared plus x squared is equal to c squared. These two add up to be 2x squared. And now I square root both sides to get c equals the square root of 2 x squared. Now this x is squared, so I could write this square root of 2 square root of x squared, and the square root of x squared we know is x. So that's x times the square root of 2. Now this is important because if I ever know this side is 7, this side would be 7, this side would be 7 root 2. If I knew this side was 9, I could say this was 9, this was 9, this would be 9 times the square root of 2. This is a type of triangle that comes up every once in a while throughout mathematics. And so if you know the shortcut, it's a lot quicker than using Pythagorean theorem. Now there's something called Pythagorean triples. There are 3 positive integers that work with Pythagorean theorem, like 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. These triangles all work using Pythagorean theorem perfectly. You don't have any square roots, long decimals. It works perfectly. We can also take those numbers and have multiples of those, and they're Pythagorean triples also. This is the 3, 4, 5 triangle just multiplied by 2. 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. This one is the 5, 12, 13 triangle, all multiplied by 4. So this is 5 times 12, 5 times 13, and that's how we get these values. So you can take any of those earlier triples and multiply all the sides by the same number, and you'll get a new triple. Our last part of today's lesson is finding the distance between 2 points. Now finding the distance between 2, 3 and 7, 9. 2, 3 is about there, and 7, 9 would be further up, further over, 7, 9. Now if I want to find the distance from here to here, it's kind of tricky because it's hard to think about distance when it's a diagonal. What's easy to find is horizontal distances and vertical distances. So from 2, 3 to 7, 9, going from 2 to 7 is 5. Going from 3 to 9 is 6. So once I have that, I can just use Pythagorean theorem to find out what that distance is. 5 squared plus 6 squared is equal to c squared, or 25 plus 36 is c squared. That's going to be 61. Now if I take the square root of that, that'll be the distance. Now 61 without a calculator, I don't know exactly what the square root of 61 is without a calculator, but I do know that square root of 64 is 8. So it should be a little bit less than 8, maybe like 7.8, 7.7, something like that. Now find the distance between the points -1, 5, and 2, 7. Now on this last problem, I drew out the graph. That works. Now there's an easier way, a quicker graph we can do without actually plotting the points. I just like to think horizontally. What's the horizontal distance between -1 and 2? Horizontally, they differ by 3. And now I think about my vertical distance between 5 and 7. Those two numbers differ by 2. Now to find the distance between these 2 points, I just have to look at this. So I do 3 squared plus 2 squared is my distance squared, or 9 plus 4 is 13. And now I just take the square root of 13, and that is my value. So that's the distance between those 2 points. Now try this one on your own, pause the video, and see if you can do it without my help. Hopefully you're finished. The distance between 4 and -2 is 6. The distance between 3 and 7 is 4. To find this hypotenuse, you take 6 squared plus 4 squared is equal to c squared, or 36 plus 16 is 52. Now we take the square root of 52 to be c. Now one thing about the square root of 52, we have to check, we should always check and see that we can't divide by any perfect squares. And the square root of 52 can go square root of 4 times the square root of 13. The square root of 4 is 2, so 2 root 13 is our answer. Now we're done with the lesson. So on a scale of 1 to 5, rate your understanding of the learning objective for today. Are you able to find sides of a right triangle using Pythagorean theorem? All right, and now it's time for your homework. Good luck.